This video is brought to you by mywayteaching.com.
In this part, we are going to study about measurement of very small distances and even the size of the molecule. To measure a very small size like that of a molecule, it will be of the order of how much? Yes, it will be of order of 10 raised to minus 8 to 10 raised to minus 10. So, in order to measure this molecule, we have to adapt special methods. We cannot use a screw gauge or similar instruments because the range of this screw gauge is very small. Okay, it can't measure up to 10 raised to minus 8 and 10 raised to minus 10 meters. And even a microscope has certain limitations. Okay, an optical microscope uses visible light to look at the system under investigation. As light has wave like features, the resolution to which an optical microscope can be used is the wavelength of light, which means for visible light, the range of wavelength is about 4000 angstrom to 7000 angstrom, isn't it? So, this optical microscope, it uses light wave, isn't it? The range it can measure, it is the wavelength of light. So the visible light wavelength is from 4000 angstrom to 7000 angstrom. Hence, an optical microscope cannot resolve particles with sizes smaller than this. So, which means this optical microscope can measure only up to 1 angstrom. The range is about 1 angstrom, that is given by 10 raised to minus 10 meter. So if the size is, if it is lesser than this, then this optical microscope cannot measure that. Hence, instead of this visible light, we can use an electron beam. Electron beams can be focused by properly designed electric and magnetic fields. So, instead of this light wave, we can use electron beams in order to get more accurate results and to measure even smaller ranges. The resolution of such an electron microscope is limited finally by the fact that electrons can also behave as waves. So, again, if we take this electron microscope also, the range is again, it is angstrom only, up to 10 raised to minus meter approximately, because electrons are nothing but waves, isn't it? In optical microscope we use light waves, so light is the property that it is a wave, so it can measure up to 10 raised to minus 10 meter. Similarly, electron microscope can also measure up to 10 raised to minus 10 meter. So these electron microscopes can almost resolve atoms and molecules in a material. So in recent times, tunneling microscopy has been developed, in which again the limit of resolution is better than angstrom. In the tunneling microscopy, it is little bit improved. We can measure even smaller ranges. It is possible to estimate the sizes of molecules. Okay, a simple method for estimating the molecular size of oleic acid is explained. So now I'm going to explain you the how they measure the simple molecular size of this oleic acid. Okay, molecular size of oleic acid. So this oleic acid is a soapy liquid with large molecular size of the order of 10 raised to minus 10 meter. The idea is to first form monomolecular layer of oleic acid on water surface. So how to form this monomolecular layer? Okay, the idea is to get this monomolecular layer on the surface of water to measure the molecular size of this oleic acid. So in order to get this monomolecular layer, what they'll do, let us see. We dissolve 1 centimeter cube of oleic acid in alcohol to make a solution of 20 centimeter cube. So we dissolve 1 centimeter cube of oleic acid okay oleic acid in alcohol to make a solution of 20 centimeter cube. So we'll dissolve it in alcohol, and after dissolving we get a solution of 20 centimeter cube. Then from this 20 centimeter cube we will take out 1 centimeter cube. Okay, from this 20 centimeter cube of solution, what we got after dissolving it in alcohol, first we'll take 1 centimeter cube of oleic acid, we'll dissolve it in alcohol, and we get 20 centimeter cube of solution. So in this 20 centimeter cube of solution, we'll take 1 centimeter cube again, and again we'll dilute it to centimeter 20 centimeter cube using alcohol. So again we'll dilute this using alcohol, means again we'll dissolve it in alcohol, and again finally we'll make it 20 centimeter cube solution, diluted solution. So two times we are diluting it. Okay, so what is the concentration of this then? The concentration of the solution is equal to, okay, the concentration of the solution is equal to 1 by 20 into 20 centimeter cube of oleic acid per centimeter cube of solution. Okay, so next what we'll do, we sprinkle So in the next part, we sprinkle some lipocodium powder on the surface of water in a large trough, and we put 1 drop of this solution in the water. The oleic acid drop spreads into a thin, large and roughly circular film of molecular thickness on water surface. Okay, we'll sprinkle some lycopodium powder on the surface of the water. So after that lycopodium powder will sprinkle this solution, then it will form a almost circular of molecular thickness, circular thin film it will form on the surface of the water. Suppose we have dropped n drops in the water. Initially, we determine the approximate volume of each drop. So, if we consider approximate volume of each drop as V centimeter cube, then what will be the volume of n drops? The volume of n drops will be equal to n into V centimeter cube, isn't it? Yes. So the amount of oleic acid in this solution, what will be the amount of oleic acid in this solution? That is given by volume, that is N into V, by concentration, that is given by 1 by 20 into 20 centimeter cube. Got this? This solution of oleic acid spreads very fast on the surface of water, and it will form a very thin layer of thickness T. So as we can see, it will spread on the surface of the water very fast. Okay, it will spread on the surface of the water very fast, and it will be of thickness T. Now how to find this thickness T, isn't it? We have a method for that also. In order to find the thickness T, we should know two things. One is volume of this film, that is formed on the surface of the earth, surface of this water, and one more thing, the area of the film. If this spreads to form a film of area 8 centimeters square, then the thickness of the film is given by the thickness is given by volume of the film by area of the film. Got this? So the volume, as I already told, here it is there, that is given by N into V, and area is we can write it as 20 into 20 centimeter. So this is the thickness. Okay, if we assume that the film has monomolecular thickness, then this becomes the size or diameter of a molecule of oleic acid. The value of this thickness comes out to be of the order of 10 raised to minus 9 meter. So if you assume that this oleic acid forms a monomolecular layer on the surface of the earth, then we can say that is the thickness of the molecule of oleic acid. Okay, so the thickness of molecule of oleic acid, it comes out to be of the order of 10 raised to minus 9 meter. Okay, It is 10 raised to minus 9 meter.